My name, as Tom says, Dominic Wind. I am the 4D lead on the Crossrail project within the Crossrail technical team. Today I'm going to talk to you a little bit around how we manage and produce visual project planning, 4D modelling on the Crossrail project. So what is Crossrail? Crossrail is a new railway for London and the South East. It runs for about 120 kilometres from Reading in the west of London out to Shenfield and Abbey Wood in the east. The project can be roughly split into two parts. We have surface works that are being delivered by Network Rail, who are the UK's national rail infrastructure manager. And that's very much sort of tying in and integrating with existing railway and making it fit for purpose. And then we have the central section works, which is the section in red, which is the subject of this presentation. That's been delivered by Crossrail Limited, who I work for. Just some stats about the project in its entirety. It's 42 kilometres of tunnel. They're twin bore tunnels, so 21 in its entire length. It's 37 new stations in total, although that does include sort of renovations to existing stations. Sorry, I'm just going to jump back. I'm not sure why I jumped. We go through 19 boroughs and there's 5 separate tunnel drives. Within the central section works, that is completely new railway. There's 9 brand new stations from scratch, and that can be split in, again, roughly into two parts. We have tunnelling and SEL. I don't know if anyone's familiar with SEL, but it's sort of a method for creating underground spaces. And then we have stations, portals and shafts. So tunnelling, there's a couple of pictures of our running tunnels there. Tunnelling progress. This is a graphic of roughly where we are. It's a little bit out of date. We're actually about 90% complete on our tunnelling. Sorry if there's a timer on this for some reason, it keeps jumping. We've essentially just got the last little section between Farringdon and Whitechapel to complete. Middle of this year we should be completely finished with our tunnelling. Some pictures of the SEL structures. The bottom left picture there, I believe you can fit something like 8 double-decker buses in the height of it. Again, it broke some record. I think it was the largest underground structure in Europe. But this gives you some of the idea of the tunnel in SEL. SEL, just for information, is about 60% complete, so we've still got a little bit to go on there. The other half of our works is the stations. We have 9 new stations in total, 8 subsurface stations and 1 completely fully surface station. So we have our station at Paddington, there's a station at Bond Street, Tottenham Court Road, Farringdon, Liverpool Street, Whitechapel, station at Canary Wharf, and Woolwich. So as I say, they're our subsurface stations, so they go down up to 7 stories. So what you see in there is kind of the tip of the iceberg. And then we've got Custom House, which is our, as I say, it's our fully surface station, so there's no underground structure there. So that was a very quick introduction to the project, and that hopefully just gives you some idea of the kind of work we're implementing 4D or visual planning on. This next section we've called it visual planning enablers, but essentially it's the building blocks or the steps that you need to put in place. Sorry, it keeps jumping around, so I don't know what it is. So the steps you need to put in place before you even start 4D, before you even start thinking about it. This section often gets overlooked by a lot of people, but we spend a lot of our time and effort in this area for reasons that hopefully will become clear. So the first part, 4D, as you probably all know, is 3D. Although it must be said that we do sometimes use 2D data as well, and we have been successful in using that. But Crossrail is a 3D job. All permanent works have to be modelled within 3D object-orientated software. And we have a whole team that is purely there to verify and enforce these requirements. We have a list of requirements on the job that every person who signs up to a contract on the Crossrail project has to abide by. This is sort of less than 1% of those requirements. But why are they important? Well, if we just take the top one, for example, the deliverable drawings must be generated from the model. This ensures that the model is always up to date. I don't know if you've ever come across this situation where the model gets dropped to get the design for a certain type period. The next thing you know, you're trying to plan with out-of-date information. It's not as effective. So we have this series of requirements that try to keep the model up to date, keep it relevant, and ensure that there's no missing parts to that model. So in much the same way as we have requirements around our 3D modelling, we also have requirements around our program or our schedule data. I won't go into the requirements in this because I'll touch on them in a bit further down, but again, we have a separate team, a planning team, that will accept the planning data before it goes into our databases, our central systems. And that's important that the two teams, the two sets of data, the 3D and the program, are verified and accepted interdependently or from the 4D team. Because we want to try and make 4D as non-disruptive as possible. What we don't want to do is get into a position where we start dictating to the planning team or to the modelling team what they must do to change their sort of business as usual. We want to dovetail into that, because then it just ensures maximum buy-in. So now we've got those two bases of data that we can rely on and we can make decisions on. We can now start looking at some of the sort of smarter things we're going to do with this, and this is talking sort of in general terms, not just in 4D, but Crossrail put together this document called, we're calling it the BIM use case matrix, and essentially this just lists everything that we in the UK, I don't know how this translates to the US, but we in the UK refer to these kind of things as BIM. So there's things on here like field BIM, using the model out in the field, interactive design reviews, phase planning, construction sequencing. It gives a brief description of what they are, who leads the discipline, roughly where they come in the project. But probably the most important one for us is it gives a general idea of the value that you can expect to get from these BIM use cases. Now that's important because, again, in our experience, we find that you get more value out of doing these kinds of exercises if there's a real need to do them. So once we've got those two bases of data that we can use, we've identified a need to use them. We do a BIM execution plan, and this just essentially formalises what we've just agreed. It documents what we're going to agree, amongst other things. But what's important to us is it kind of puts down in writing what we're going to deliver, what you're going to expect to see at the end of this. So there's no surprises. People don't get to the end and expect it to solve a problem that it never would. So, as I say, that whole section was essentially the steps that we put in place and the work that we do before we even go near a package like Synchro, before we start producing 4D models. This next section, as you can see from the screen, is what we consider to be 4D or visual planning. why we do it, and sort of how we control it. So what is it? Well, this may not come as a surprise to people in the room, but we found again in our experience that there seems to be a huge range of work that people sort of lump under the 4D umbrella. And I'm not making any judgments about how sort of far along the process people do that, but to us this is what we consider to be visual planning. So we have our verified geometry, and it's linked to program in the same way as everywhere else. The important thing here is, as I say, it's verified. We can make decisions on it. So again, we want to get to the situation where we can sit in a room and with sort of maximum confidence make decisions based on that data. What we don't want to do is be in a position where we use the 4D to give us an idea and then have to go away and verify that that is actually a problem, you know, that we have got the latest models, that we have got the latest schedules. It may sound obvious, but you know, when you're sort of dealing with £750 million station, for example, you can't make decisions unless you're absolutely 100% sure that that data is correct. So yeah, as I say, we've linked our geometry and data, program data in the usual way, and this helps us just check the logic, and that's as far as we go at this stage. We don't get into anything other than is X being built before Y, and you know, is that right? Do we need to build Z in front of that? If that's enough, we stop there. If it's not, we can move it a step further and we can start looking at specific areas. So again, we sit down with our PMs and our construction managers, say, have you got specific issues on this? This will all be documented in the BIM execution plan or 4D implementation plan beforehand. So we can zoom in on these areas of interest if required. From that, we can find the tasks that are happening in that area. Again, no real surprises, but we resource load our programs, and this is where that verification process really comes into its own, because we ensure that it's resource loaded to an appropriate level. Again, you know, we've had situations where someone just puts a digger in and just assigns that to tasks. Well, you know, if you do that, then how do you know that digger isn't needed in several places along the site? So that's really the next stage, is once we've decided that yes, those resources, we're happy with those resources that are on that task, we may look at the constructability report, see the sort of progress rates that those resources are based on. We then can start looking at okay, are those resources used in other places? Are we over relying on those resources? And then the last thing we do is we cost load our program. So what this does is really helps us out the step before. If we ever get to the situation where we don't think the resources are appropriate, we can start getting a rough idea of how much it's going to cost us to either increase those resources or, you know, increase the duration of the task, or a combination of the two. It's important as well to know here that this isn't 5D. We're not a 5D project. We're a 4D project that's using cost information to help us achieve true buildability and not just correct build logic. So that's what we consider to be visual planning or 4D. This next slide is really it's why we do it, and again this comes up a few times because we are a client. A lot of people don't understand why we as a client need to do 4D. They think it's a contractor's tool. So this slide represents every contract that's on Crossrail. Each one of those rectangular boxes is a contract. Again, to give you just some example, the columns running down represent our stations. The lines that run sort of horizontally are our tunnelling. Each one of those stations is I think approximately 750 million pounds. Our tunnelling contracts are about £1 billion each. So those contracts, the potential for miscommunication between those contracts is vast, and that miscommunication is not only multiplied by the scale of the contracts, it's also multiplied by the interdependency of them. So again, it may sound obvious, but you can't start digging your hole until your enabling works are done, until your power and water have been diverted round. On one project, that's reasonably easy to manage, but when you've got 9 stations and 5 tunnelling drives going on, it gets a lot more complicated. So what does that look like in reality? Well, this is a 20-metre section of a typical station. It's not specific, but what we've done here is colour code. We've assigned a colour to each contractor that's working in that stereotypical station, and if I just play that, and it's got the correct build logic. So the red there is our stations contractor, the blue around the outside is the tunnelling contractor. Stop there. There we go. Sorry. Yeah. So the blue is the tunnelling contractor. The red is the stations contractor. We've got purple there representing our track and system-wide contractors, and then we have specialist platform screen door contractors there. So we've only got 4 contractors working in that 20-metre section, but they have to hand over the site to each other multiple times. So there may be up to 10 handovers of site within that one section of works. If we roll that up to the next level, this is essentially just, this is a reasonably simple animation, but all that is showing is that work site that I just showed you isn't a static work site. It's linear. We have 240 metre platforms, and we don't have the time to let one contractor finish the entire platform before he hands over to the next, and that risk is then rolled up, because in this particular example, the only way to get into these tunnels is through the access shaft. You can just make out in the bottom right hand corner there. That's also the access for our stations team. So for every day that they're in the tunnels working away, our stations can't get on with their works. So one small problem with one of those contracts, in one of those handovers, can roll up to have a huge effect on a station. It could, potentially delay the opening of Crossrail for 2 or 3 weeks if left unmanaged.